A boat accelerates at a constant rate of 12 feet per second squared. The boat travels 140 feet while its speed changes to 60 feet per second. The initial velocity in feet per second was most nearly. So we're going to go shortly in the FE handbook, but first I would like to lay out everything that's given to us in the problem. So I'm going to write down, we have acceleration is 12 feet per second squared. Next, we have the distance. The boat travels 140 feet. So we have distance equals to 140 feet. And then we're given this information that the speed changes to 60 feet per second. So the boat starts at a certain speed and then it changes to 60 feet per second. So we're going to say V equals to 60. Well, this pen gives me a lot of issues today. Okay, so now based on what we have, we're going to go to FE Handbook and try and find a formula which includes all of the things we have that's going to help us to find the initial velocity. So here we are already in the dynamic section, but what I want to do actually is I'm going to start from the beginning, I think. Because very easy, I can say, well, let's just write kinematics or let's just write particle rectilinear motion and then we're going to get to these formulas. But what I'm trying to do here is to try and help you out if you're on the exam and you have a problem like this and maybe you don't know how to solve it. Just go to the dynamic section and scroll down little by little and you're going to be able to find the formula that involves the final velocity, the initial velocity, the acceleration, and then the distance. Let's go ahead and write this formula down. Let's see if I'm able to do that. So we have v squared equals to v0 squared. Okay, v squared equals to v0 squared minus 2 multiplied by the acceleration and multiplied by final distance minus initial distance. In our case, the initial distance equals to 0. So the S0 equals to 0. So this formula becomes v squared equals to v0 squared minus, this is squared here, minus 2 multiplied by acceleration and multiplied by the distance. So now from this formula, we have to calculate for V0. So from here, I'm going to continue and say that V0 equals to square root V squared plus, and then we're going to have 2AS. And this equals, so let's go ahead and substitute by what it's given in the problem. Let's do this. So V equals to, V0 equals to, V is 60 feet per second. So we have 60 squared plus 2 multiplied by A is 12 feet per second squared, and multiplied by the distance, which is 140 feet. Again, I just want to apologize about my writing. I'm having really issues with this pen today. Bear with me, please. Just making sure our units match. We have feet, 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 so we're good there. So let's go ahead and solve this. Use your calculator. I'm going to do 60 squared, 2 times 12, that's 24. 140 multiplied plus square root. Okay, well, obviously you've probably been screaming at me right now that this is actually plus and not minus here. So plus, which means here I have minus. So let me delete it. And here as well, we have minus. And now we're going to get the right answer. So let's go ahead and do this again. So we have 60 squared, 140 multiplied minus square root. This gives me 15.49. So I get 15.49, or I can round up and say 15.5 feet per second. And so the correct answer is C. So very straightforward problem, and I just wanted to point out the fact that a problem or a similar problem was on the FE exam. So I think these are, you're gonna find them there. So it's important for you to kind of know how to solve or where to find the formulas and how to go around them. I'm gonna keep it short this week. This is pretty much it. My pen is not helping me either. So that's gonna be it for today. Keep on practicing the FE problems as many as you can, because this is the only way that you're gonna get better at this. Hope you have a wonderful week. I'll see you next time.